Hi, welcome to this lesson on trigonometric functions, part 1. Let's have a look at question 1. We're given the equation sine of x plus 60 degrees plus 2 cos x equals 0. We want to show that the equation can be rewritten as tan x equals -4 minus square root 3. Alright, so let's start off by writing what we have here. And I notice immediately compound angles. Sine of a plus b. So I'm going to expand that using the compound angle formulae. So it's going to be sine x cos 60 degrees plus, because there's a plus in the middle here, cos x sine 60 degrees plus 2 cos x equals 0. Okay, cos x, that's a special angle. Cos of 60 degrees is a half times sine x. And similarly, sine of 60 degrees is a special angle, that's root 3 over 2 times cos x plus 2 cos x equals 0. Okay, these all have a denominator of 2 except 2 cos x, so I'm going to multiply both sides by 2. So I'm going to get sine x plus root 3 cos x plus 4 cos x equals 0. And then I'm going to divide everything by cos x because I want a tan x in my solution here. So sine x divided by cos x is tan x. Root 3 cos x divided by cos x is just root 3. And 4 cos x divided by cos x is just 4. Okay, and then taking all the terms to the right-hand side, I have tan x equals -4, negative root 3. Okay, and that's exactly what we wanted to show. Awesome. Next, we want to determine the solutions of the equation in the interval. X is an element from -180 degrees to 180 degrees. Okay, so we know that the solutions, the general solutions to this equation, that equation could have been written as tan x -4 minus root 3. That's what it is equal to. Okay, so using that simplification in the previous step allows us to solve this equation much easier. Okay, so let's get out the cast diagram. Now, where's tan negative? Because this is going to be a negative number, right? If I put in -4 minus square root 3, it's going to be a negative number, -5.73. So it's negative. So tan's negative in the second and fourth quadrants. So therefore, our reference angle is going to be tan inverse of the positive of this number. So shift tan inverse, +4 plus positive root 3. Okay, so that's going to be 80.01 degrees. Just double check that, 80.10 degrees, sorry. So that's the reference angle over here in the first quadrant. So therefore, in the second quadrant solutions, we're going to have the angle x is 180 degrees minus this value. So 180 degrees minus that answer, minus answer. We're going to get 99 points, let's say round up to one decimal place. So 99.90 degrees. Okay, so that's 180 minus reference angle plus k times 180. Because the period of tan is 180. Okay, we only need one solution when it comes to tan when we're solving general solutions. So this will be the one that we are examining. Okay, because the fourth quadrant solution is just going to be 180 plus that. And we'll have that solution already encoded in this general solution. Okay, so determine the solutions within this given interval. So when k is 0, your x value is 99.9 degrees. All right. When k is 1, what do we get? So plus 180, 279.9 degrees. Okay, is that within this domain? No, so not applicable. And then anything greater than 1 will be not applicable. What about k equals -1? Let's try that. So it's going to be minus 180, okay. So that's going to give us -80.10. And that is within that given domain. So that is applicable. And then anything less than -1, so -2 onwards, will be outside that domain. So these are the two solutions in that given interval. Okay. Now we want to draw the graph of g of x equals sine of x plus 60 degrees for x in that given interval. So what they've drawn here for you, this is the graph f. And f is given by this function f of x is negative 2 cos x. Okay, so we want to draw sine of x plus 60 degrees. So let's think about this. The original parent graph was sine, right? Roughly looking like that. 0 degrees, 90, 180, 270, and 360. Okay. Plus 60 degrees. So that's in the general form of sine of x plus p. So that's a phase shift, a horizontal phase shift of 60 degrees. And because it's positive, it's phase shifting to the left by 60 degrees. So in theory, we expect the graph to look something like this. Okay, so here is sine x, so the graph would just be a phase shift of 60 degrees to the left. Okay, but whenever you're sketching functions, my recommendation is to definitely make use of the table function on your calculator. So you can go mode 7 for table. Okay, so if you want to draw two functions, the calculator will allow you in some cases, but for most cases, if you're just drawing one function at a time, in our case, f is going to be sine of alpha x plus 60. Make sure your calculator is in D for degree modes, otherwise this will give you wrong values. Okay, we're not drawing a second function, but we want to start where? Well, the domain says from negative 120 all the way up to 240. And the steps that this graph has given us is in 60 degrees, so let's stick with that. Okay, so negative 120 degrees will give us negative 0.866. So that's somewhere around here. So if he has negative 1, positive negative 8.66 is somewhere up there. So there's that endpoint there, negative 120 degrees, negative 0.87, if you want to round off to 2 decimal places. Okay, but that's a very special trig value. That's root 3 over 2, negative root 3 over 2. Okay, at negative 60 degrees, it says it's 0. So let's mark that. Okay, and whenever you sketch any function, it's always important to label things like x-intercepts, y-intercepts, turning points, endpoints, etc. Okay, at 0 degrees, it gives us that same 0.866, which is root 3 over 2. Okay, so 0 degrees, it's going to be somewhere up there. So 0 degrees, if you want to write root 3 over 2 as an exact value, you can as well, that's fine. And then let's bring back up. 60 degrees gives us exactly that same value again. So we'll notice something here, that there's probably going to be a maximum turning point somewhere up here, which we need to locate. All right, and I'll show you exactly how we can do that. 120 degrees, it's 0, okay. And then 180 degrees, it's negative root 3 over 2. Okay, and then 240 degrees as well. Okay. Now, this is not the full picture of the graph. So how do I get where those turning points are going to be? So what I'll do is I'll click AC on my calculator and it brings me back to that function. But I have a hunch it's around halfway between these. So I'm going to go in the same things, but now my steps, I'm going to go in 30-degree intervals. So now look at that. So now you get more information. The more information you have, the more accurate your diagram becomes. Negative 90 degrees is negative a half. Okay, so negative 90 degrees over here, that's negative a half. Negative 60 degrees, 0, we've got that. Negative 30 degrees is a half. Okay, so that's up here. 30 degrees is 1. Okay, interesting. So there's 1 here. Okay, and because this is, there's no amplitude value other than 1 in front here, and there's no plus q value here, we know that the range will still be between -1 and 1 for the standard parent graph. So 1 is going to be the maximum value here, so 30 degrees 1. Okay, we've got 60 degrees. 90 degrees, again, is given as a half. 120 degrees, 0, we have that. Negative 150 degrees is negative a half. So that's over here. 180 degrees, negative root 3 over 2, we got that. 210 degrees, that gave us a minimum value of negative 1. Okay, now that we've got all the points, we can curve them together and get a picture of the sine graph. Okay, so this is the graph G. Okay, and label all important points. So the important points I would label are the endpoints, which we've got here. Any intercepts, x-intercepts negative 60 degrees 0, 120 degrees 0, okay? Y-intercept 0 degrees root 3 over 2, and then turning points. Max one here at 30 degrees 1, and minimum one here at 210 degrees negative 1. Okay, so we've successfully drawn that graph. And then lastly, determine the values of x in the interval that we were given when we sketched the graphs, for which sine of x plus 60 degrees plus 2 cos x is greater than 0. So let's think about this for a second. This was g of x. That was what we assigned the value g of x, sine of x plus 60 degrees. F of x was negative 2 cos x. Pay very careful attention to that. Here's positive 2 cos x. So I can rewrite this as sine of x plus 60 degrees greater than, so I'll subtract this term over, negative 2 cos x. Now this was f of x. Okay, so just make sure that you read it carefully the way the functions are given to you. So we're looking for when the graph g of x is greater than f of x. So in normal words, this just means for what x values will the graph of g lie above the graph of f. Okay, so let's have a look here. So we are looking for g of x greater than f of x. So g of x is this green graph. And can you see here's a point of intersection and here's a point of intersection. Okay, I'll call that A and that B for the points of intersection there. And then from that point of intersection, the green graph G suddenly becomes greater than, so it lies above the red graph. All right, and it continues that pattern all the way up to the other intercept B. And then after that, the green graph is below the red graph, and to the left of A, the green graph is below the red graph. So those two intercept values, did we find them? Well, if we go back, we actually did. 99.9 degrees, okay, and a y value, which I'll just call y, because we don't really need that right now. We're interested in the x values. And then the other one was negative 80.1 degrees, negative 80.1 degrees, and another y value, say y2, y1 and y2. Okay, so we know the x coordinates for A and B there. So in between that interval, the green graph will lie above the red graph. So this implies then that x must be an element from negative 80.1 degrees all the way up to 99.9 degrees. All right, so that interval right there, that is the open interval, because I do not include these n values, because at those n values, the two graphs are equal. We want strictly greater than. All right, so that's how we would do these types of trigonometric function questions. I'll see you in the next one.